Alright guys, so shown here are the velocity and acceleration vectors for an object in several different types of motion. In which case is the object's velocity changing while the speed is not changing? So the object velocity is changing while the speed is not changing. So that means for speed to remain constant while the velocity is changing, meaning the direction of the speed is changing will only be possible if acceleration has to be perpendicular to speed. So the answer would be B. And then for number 2, we have a projectile is fired from the origin at y equals 0, as shown in figure 3. The initial velocity of the components are that of each one, and the projectile reaches maximum height at p. So we're looking for the maximum height, right guys? So what we have to do is velocity times time equals initial velocity, acceleration time. So this is the equation we have to use. So 0 and some t 96 divided by 10, negative 10 for negative 10 with a t. That gives us 9.6 t for the time, right? And then the same thing for the y direction. Right, initial y plus initial velocity time plus 1/2 acceleration time is the equation we have to use eventually. So what we do is we do since it started at 0, 0, and 16, because this is the initial where it started, 96t plus 1/2, negative 10, 9.6 squared. So the negative 10 is the acceleration because of gravity, right? So then we get 1.6 minus 46.100.8 is going to be equal to 461, because we also had done this over here in order to get what we got there. Alright, so we have A and B particles. They're a circular motion, right? The acceleration for A is 4.7 times the particle B, and B takes 2.4 times as long as rotation as particle A. So B is obviously farther out than the common center, and the acceleration of 4.7 is much faster. So what we do here is we're finding the radius of motion particle of A to that of B. Is we have to find the acceleration of A and B. So you put acceleration of A over acceleration of B over each other. That gives us 4.7. And then you do the time period of A and B. Time period of B, 2.4, and time period of A, right? That gives us 2.4. And then we're looking for the ratio of the radius. So what we do is work 2 pi over t right, so 2 pi over t is equal to 2 pi over TA in our sense. And then we do the same thing for TB. So then we put them over each other, right? And that will give us 2.4. Because that is what we have for how long more is taking, which is 2.4. And then now to find the ratio radius is we do A, right, for all of it. So we're putting them all together now is the acceleration is equal to 2.4, which is the time squared, or A or B, right? And then that gives us 0.815, which in our answers is 8.82. All right, and then we got number 5 here. We're looking for the shortest time it can make a full turn when it performs an aileron roll. So centripetal force is given as this mass velocity squared over r. So we're finding the velocity. So we do velocity, and this is mass times acceleration. It's equal to ma. So then what we do is v squared equals acceleration r. So this can go like that because we take away the square. So we put in the 4 meters squared, which is the acceleration, times the wingspan, which is the radius, which is 8.9 divided by 2, right? And then we get velocity of, we get 9948 for the first turn, because we would do 4. So we're looking for, because this is the centripetal acceleration, right? So that squared times 4.45, and then we get 0.948. So if it turns for the shortest time, we do 2. So we're looking for the shortest time divided by 0.948 is equal to 6.624 seconds. All right, and then for 3, what we're looking for is, with figure coordinate 100 meters is closest to 100. Where started velocity, no final times time, is that over 42500 which is equal to 206. That's our y. So then we put that in the time one. 1,050 equals 20 seconds. That's the seconds we have. So now that we have the time, we put it in our equation, v by t 1/2 time squared. And then we get 2040.